All right. Thank you, George, and thanks, Steve, for the introduction. I'm going to try and follow the format. My name is Ionuț Florescu. I'm the director of this laboratory and another laboratory that we have upstairs. So I took the opportunity to actually use the facility to introduce myself. I'm going to try to keep it to, see, I have a timer. I practiced this talk this morning twice, and I was never able to make it to 10 minutes, but let's hope that it's a different situation right now. So let me talk about, so this project, it's a project that we started 6 years ago, 2014. I'm the PI, the principal investigator for this project. Among the team members is Professor Calhoun, who you saw, Dragos Bozdog, the deputy director of the lab, and Eric Berger from Georgetown. We have a number of students that participated in this project and a number of PhD students associated with this project. So what is this system? Well, the motivation of this project starts many years ago with a series of conferences that we had, where and we organized on the topic of high frequency finance. And high frequency finance, it's a very dynamic model, as the name says, but there were a lot of agent-based simulators at the time, and there still exist, and they all very much simplifying the real life situation. And we did not want to do that. We wanted to create something that we call a replica of a real system. And we wanted this fake system that we create to be as realistic and as detailed as possible. So the result is this shift system that we've created here. So this system has been rewrote 3 times completely in this history. It's a system that has about 300 lines of code. And fundamentally, there are 2 major implementations of the system. As you can see, there's a schematic here. This basically details how the system is designed. We have one engine, which we call it the database engine. We have another engine, which is the matching engine, where all the orders are matched. We have a brokerage center, which holds the records of all the market participants, their accounts, and how much they can borrow, how much they can lend. So, and then of course you have the clients, which are really either algorithmic systems or real people that interact with the system. So it's a pretty complex system. We use it in 2 basic implementations. In one implementation, which really not that different from replay of the market activity, with one big difference: we actually replay orders, that is bid and ask. So in some sense, we simulate the market liquidity, but in this particular system, if you send, let's say, 20,000 shares to the market, it will not be executed like it would be in a real market. It would be executed with whatever liquidity exists, but then because we're having a replay of the real market, we have to actually wait for one side of the book to fill this market order. So it is some limited liquidity capability in this implementation. We use this implementation purely for teaching. Now, the other implementation, we have an agent-based liquidity-driven market. So in this implementation, we really have agents who are driving the market. In this market, if you put the 20,000 shares order, this is going to drive the market completely. It's just like a real market, and we can use this to study all sorts of things. We have published so far 2 papers, one just detailing the system and one where we're trying to implement something called the frequent batch auction, which is designed by some people in Chicago, in the University of Chicago. So we have a paper that we're working on where we're detailing how this implementation and the flaws that appear, or the advantages that appear in such an implementation. So that's basically the system. It's, like I said, a very complex system, something that we've done for the longest. So as you can kind of hear, unlike most of the systems that are presented here, this is a much more developed system, I think, than anything that was presented. So why are we coming to you, and why do we need your help? So that brings me to the next point, the challenges. Well, there's two major issues with this system. Number one is the system is very, very complex. So the entire system is written in C++. We connect every piece of it with fixed protocol. So basically it's really realistic, but that being so realistic also makes it very complex. So there is a learning curve to starting to utilize the system, and that's what we need help with. So one, we need to deploy this system into a location that makes it accessible for everybody in the cloud system. And also we need to basically create tools for the users to be able to create scenarios, to be able to study situations with the touch of a button. So that's the cloud deployment and system accessibility task. And the second task is how can we make this system to not only handle equity, which is kind of like what everybody does, but also handle options that are written on equity, handle futures that are related to this. For example, today, if you want to trade the S&P 100, you need to go to E-mini to CME. But if you want to trade the options related to the same instrument, you have to go to CBOE. And if you want to trade the components, you have to go to NYSE or NASDAQ. So there's all these things that you need to go through. Each system is different. Whereas here, this one system that hopefully can do, or simulate how this works. I have more details about each one of these tasks. Basically, what we want to do, we are in discussion with AWS through the help. Oh, I should actually mention this system was initially supported by Chicago Mercantile Exchange Group. Their foundation gave us funding for the first 3 years of the project. Most recently, Capco very nicely agreed to support part of this project to continue development. Their team actually met with us. It was an exceptional collaboration. Hopefully, that's going to continue in the future. Through them, we were able to talk to AWS, and AWS were very interested in trying to come up with a solution to integrate the system and make it part of. Apparently, they told us something that I had no idea. They had something like 300,000 data sources, like something unbelievable. They had this website that they showed us where it lists all the data sources. You had no idea there's so many data sources in AWS. And so anyway, that's the, I should also mention the competition. We've run 2 student competitions so far in 2000 last year and this year during the pandemic. And these were all closed to Stevens, basically using Stevens students. We had about 30 students every time we run it. The plan is when we discovered many bugs, we discovered many things that we can do differently. It tremendously helped us. The plan is next year, hopefully we're planning to do this at the level of these 4 institutions, because this gives you a forum where we can actually expand a little bit. And then the next year after that, hopefully to multiple universities. The expansion to multi-assets, this is just basically pointing out that the system is entirely modular. It's written in C++, which is an object-oriented program. So that's the reason we had to redevelop and rewrite the system 3 times just to be able to make sure that it is extensible. So that's this. I'm going to just mention the milestones. We're planning on 2 reports, semi-annual reports. We're also planning to having monthly discussion. This for us is extremely important. One thing we discovered is that there is the research and the academia. There's also the industry. And the industry, if they're going to ever use this, we need to get their input, because we get so much information from discussing things with the industry participants. The budget is, as you can see, split into various things. Majority of it is the student support. So that's extremely, extremely important. I think I'm getting close to 10 minutes. So I'm going to go to these conclusions and the membership benefits. So first of all, the plan is in 2 years to have a fully functioning system deployed on Amazon Web Services or Microsoft Azure or Google, whatever, Hangouts. I'm not actually, Google has its own. See, I'm actually at the end of my 10 minutes, but let me go through this slide pretty quickly. An easy to use interface that you can actually program and use it to design various type of scenarios. The system, the idea is to provide preset scenarios which are designed to stress algorithms. A complete set of, this is actually quite important, as you may or may not know, high frequency finance, there was a rule. Anyway, there's a very long story that I can make now, but the interest of time, let me just point out that there are very little tool to assess the risk related to algorithms, high frequency trading algorithms, other than just stop them if they seem to be going a while. And there is no pre-training, there is no pre-testing, there is, there's only like, here is a box, test your algorithm with a box, but there's really no consistency into, let's stress this, let's certify that this particular type of algorithm is actually not going to go, insane. So what's the benefit of a membership? So basically, I had to think about these, but I would say of course, we can design a specific instance for you. We can work with you, and of course, that's us in the first place. As I said, being an academics and working with the industry is tremendously beneficial for us in the first place. And I would like to point out the third point. Since we had students from the beginning of this project, since 2014, I want to point out that our graduates are working to everywhere. In fact, my system administrator just reminded me that one of our students who graduated last year is working on providing this video for you today because they're working for Google, for YouTube video. So we have, for whatever reason, our graduates happen to be finding much better job. When I say much better, I mean much better paying job lately in the high-tech industry rather than the finance industry. So hopefully that's going to change once this high-tech is going to go into the finance industry, as Professor Carbon mentioned in the beginning. Hopefully this institute is going to, contribute to that. So hopefully we're not going to lose our graduates to so-called high-tech industry. So anyway, that's my presentation. Thank you very much for listening. I appreciate very much.
Okay, thank you, Professor Florescu, for your presentation. So we have one question from the audience. So the question is, which goals out of the three major goals, financial stability, investor protection, and preventing financial crimes, are the system focusing on? In other words, which financial regulatory goals you are trying to focus on for this tool?
That's a really good question. The real answer, I don't know. The system as designed is designed to basically be as versatile as possible. I mentioned, I think it's the third time I mentioned that we read all the things. The system is fast. Basically, imagine any option of anything that you want to do, you can put it in the system and study and actually do it. You can actually take this thing and create an exchange tomorrow and do it tomorrow. Now, the things that are in the question, they're all very important. Actually, financial stability, of course, is the biggest thing to do. And that's the major motivator of this particular. That was the initial idea. We want to go from the micro to the macro because that's the only way you can do it in a logical way. The stopping of the algorithms that go crazy, of course, that's one of the immediate applications that you can see of this project. And what was the third one? Sorry. What was that? Sorry, Steve?
So essentially, the three goals, right? Financial stability, investor protection or preventing financial crimes?
Yes, investor protection. So that actually is part of the regulation that I mentioned, and in fact, that's probably one of the most, I should say, easiest to I don't know if it's easiest, but one of the things that are immediate actually, possibly in the system, because the big investors, they have a fiduciary responsibility to demonstrate, that this execution of their algorithms is not taking away from the money of their contributables. So that's one of the things that we discussed with Goldman Sachs many years ago.
May I add a comment?
Okay.
Yes.
So we have another question that's very quick. So the question is, in my world, we call such testbeds digital twins. Will all your data be past data, or you will use stream data to get insights? How about cryptocurrency markets?
So it's actually both. Streaming data, every data has to be streamed, but of course you go to the database and you can check the data. We have the replay, which is actually using the real data. And then we also have this other implementation where we create data. So it is generated data and replayed data.
Okay.
I just want to add one quick comment here. This is because I am on the list of as this project as well. We're getting a lot of interest in commercial potential for this project, and some of the participants on the call, we've had discussions about whether or not this particular piece of technology can be spun out and commercialized. And so I just want to mention that because in the context of our discussions with other industry participants, that's a dimension to this project that may be a little bit more advanced than some of the others.
Okay. So there are more questions, so we'll just wait toward the end of this session. Okay, thank you again.